Good morning. In the United States, at our conferences when we announce somebody, we usually say, ladies and gentlemen, Rich Kilmer. And then everyone's like, yeah, but no, we won't do that. Yeah, there you go. Unhook this thing for a second. I'm going to be talking about MacRuby today. And MacRuby is, well, first, a little bit about myself. I've been working with Ruby since 2001. And Ruby, I came from the Java world, and after writing 600,000 lines of Java code from 95 to 2001, I was this burnout of Java. Started learning a lot of other languages, and I found Ruby, and I kind of fell in love with the language just as a language. There were no graphics libraries. It was really horrible, but I loved the language as a language. Matter of fact, when I started with Java, it was the same thing. I started with Java before they even had a UI on top of Java. So I just really loved Ruby. And so we do our production development with Ruby and Rails these days. I work with Chad Fowler. But MacRuby, just as Ruby was back in 2001, is kind of where my passion lies right now with Ruby. But the entire time, this last 8 years or so, I've just never stopped falling in love with Ruby. MacRuby is a project that is sponsored by Apple, actually being developed by this gentleman, Laurent Sansonetti. Laurent is Belgian. He actually lived in France for many years and has recently moved to California. One of the big controversies in the MacRuby community, and you know, in any development community there are controversies. It happens, right? The biggest one right now, which has really caused a lot of problems with people, is how you pronounce MacRuby. Now, Laurent, being Belgian, actually pronounces MacRuby. Do we have audio? Yeah? Audio?
MacRuby.
Ah, there it went. We'll get it. Bring up the audio a little bit here. Okay, so here's Laurent's pronunciation of MacRuby.
MacRuby.
Now, the thing is with Belgium, right, there is a conspiracy, and this gentleman is actually trying to fight the conspiracy. I don't know if anyone knows him, Alan Francis. He's kind of the Fabio of Scotland, right? He puts on Scotland on Rails. And this is the way he pronounces MacRuby.
MacRuby. MacRuby. MacRuby is Ruby for Scottish people.
Right? So the audio can go off now. So I kind of like that, right? MacRuby, right? Oh, you know. Now I'm from California, so we'd be like, MacRuby, man, totally. But anyway, so actually onto the presentation. Apple has a long history of supporting Ruby on OS X. Actually, all the way back to OS X 10.2, Ruby shipped with OS X. And it's the actual only major operating system company that ships Ruby on it, and the other one in Redmond doesn't yet. Anyway, so in 2002 they shipped they shipped Ruby 1.6.7. What was great was we had early versions of OS X, and we were saying, oh gosh, please ship 1.6.8. 1.6.8 was actually the stable version. 1.6.7, all the odd numbers were supposed to be development versions, and you weren't supposed to use those. 1.6.8 was the stable version. And so there was this wonderful thing of every time a new version of OS X came out, the Ruby community would get together, blog some things about how to upgrade your Ruby on the operating system, because the Ruby that shipped with it you couldn't actually use. So Ruby 1.6.7 was unusable, but at least it shipped on the operating system. On 10.4, Ruby 1.8.2 shipped, which of course at the time 1.8.4 was the one everyone was using, and so we all had to reinstall the Ruby on the operating system in order to use it. Around 2007, so this is when Leopard came out, this is when Laurent took over Ruby management in the open source. So there's a whole division inside of inside of Apple that deals with the open source components of the operating system. It's led by Jordan Hubbard, who Jordan was the kind of behind the entire FreeBSD project, and Apple hired him on probably 7 years ago to take over the Darwin operating system, which is the underlying operating system in OS X. Laurent at the time was in Europe, and he contacted us. It was great. I got this email that said Apple would really like to ship Ruby correctly with the operating system, and we'd like to ship RubyGems, which was awesome, and we'd like to ship Rails with OS X. And it was just like, oh my gosh, you know? The operating system, or the language, I think it was my operating system, the language that I love so much is going to ship with the operating system I use every day, and I'm not going to be able to use it. That's going to be awesome. So when Leopard came out, this was the first version of Ruby that was actually usable. And I never had to upgrade it. It was great. I didn't build my own custom version of Ruby with Leopard. I used it. It shipped with RubyGems, RubyCocoa, which I'll talk about in a couple of seconds, of course Rails, a whole series of gems. And of course Snow Leopard came out, about a month and a half ago? And Snow Leopard shipped with the latest version of Ruby right now, which is Ruby 1.8.7, RubyGems, Rails 2.3, and again, the support for this is just getting better. So this is the traditional Ruby, which we call MRI, Max's Ruby Interpreter, MRI. There are other Ruby runtimes like JRuby, IronRuby from Microsoft, and in the, I think it was at RubyConf 2007, Laurent came, and actually it was just, because it was just after Leopard itself shipped. Laurent came and he said, I want to talk to Mats about a project I have, an idea I have, and that is to develop a version of Ruby that integrates seamlessly with OS X. So Ruby ships, it will run on all kinds of different operating systems, like 30 different platforms Ruby runs on. But this one is really tightly coupled. He called it MacRuby, right? So MacRuby, actually in the fall of 2007, he started this project. And this was a very ambitious project. He said, I want to merge Ruby with Objective-C. So Objective-C is the programming language that is used on OS X for developing most applications on OS X. And he said, I believe that I can merge Ruby and Objective-C. And so that project started late 2007, so it's really only about a year and a half old. So everything I'll talk about today is really only about a year and a half old of development. So Apple's goals. Apple really does want to make OS X the best platform for Ruby developers, right? They have at least one person in the entire company that's focused on it. But it shows their commitment, right? They have one person that's working on this, but they really do want to make it the best platform for Ruby developers. And the goal of MacRuby is to make Ruby a first-class Cocoa programming language. So the term Cocoa, Apple uses all these creative, markety words, like Cocoa and Darwin, and it's so cool to come up with a project name. Actually, I will say that naming your projects in the open source community is about the most fun part of a project in the open source community, coming up with a cool name. Maybe second to that is a logo, right? But the name is pretty neat. So Cocoa is the graphics library of OS X. So that's the UI, everything you see is Cocoa. But when I say Cocoa, I mean really Objective-C and all the frameworks which are accessible on OS X through that language. I put it under Cocoa. So they want to make Ruby a first class. And actually, I will say this not as Apple, but as, because I don't work for Apple, I will say to make it the best. To make it the very best Cocoa programming language on OS X, which means better than Objective-C itself. Ruby should be better than Objective-C because Ruby as a language is better than Objective-C. No one will argue with me here, or else I'll take you out back. Because that's what we do with people like that. No, but Ruby is a fantastic language, and MacRuby's goal is to do that. So let's talk a little bit about the stack on OS X. You have the user experience layer of OS X, that's Cocoa, and application frameworks. You have the graphics and media layer down below that, and then you have the Darwin operating system. And programmatically, you program down at the bottom in really C and C++ if you're doing Darwin development and graphics and some of the application frameworks. But these upper layers of development, you can actually use Objective-C to program to. And Objective-C as a language, as a runtime, is it's an object-oriented programming language. So it's kind of, at the time when C++ was being thought about, Objective-C, there was like these two competing ways of making C object-oriented, C++ and Objective-C. Next, when Steve Jobs left or was kicked out of Apple, however you look at it, when Steve Jobs left Apple and started Next Computing in, I think it was the late 80s, he actually started with this language Objective-C. This was a language developed by a series of people, but Brad Cox was one of them. And this added objects to C. And they developed their entire Next operating system on top of this language. And the runtime is really, really similar. The object model of Objective-C is very, very close to Ruby's object model. If you look underneath the covers and the way objects work and the way things are dispatched to objects and the way you can dynamically change things. But of course, Objective-C is based on C, so it's a compiled language, whereas Ruby's an interpreted language. So although the runtime of Objective-C is very dynamic, the language Objective-C, because it's compiled, is static. I mean, you think of it statically. So one of the interesting things about MacRuby is when you put Ruby on Objective-C like this, you can really take advantage of the dynamic runtime of Objective-C. And for Objective-C programmers, like people in Apple, when Laurent shows this to them, they kind of freak out. They're like, wow, I can really now take advantage of this dynamic runtime, and I've never been able to do that with Objective-C itself without jumping through a lot of hoops. So Objective-C is, does all these higher layers on OS X development. So, bridging Ruby and Objective-C. There was an effort that was actually started by Hissa in 2001, and it was called RubyCocoa. So, Ruby and Cocoa. And the goal was to actually allow Ruby to seamlessly create and call Cocoa, the Cocoa layer, which is the Objective-C layer. And so this is in 2001. I had just gotten a Mac around this time, so I was very excited about RubyCocoa. I was a very early adopter of RubyCocoa. And I think there was like version 0.1 and 0.2, Hissa posted an update. Now this is before RubyGems, before anything, right? There was like tarred zip files up in some repository somewhere that you downloaded and you did make and make install. So what was great was he published a new version and said this new version's out, and there's probably 3 of us in the world that were actually playing with it at the time. But I got it really quick, and this is the middle of the night in Virginia where I was, and I start install it. Well, whenever he installed RubyCocoa, he would install it in his user library directory, because RubyCocoa installed itself as a framework. I, not knowing any better, installed it in my system library folder, which is /library. So there's like, your username /users/rich/library, my libraries. And then there's /library. That's where the entire operating system's libraries and frameworks go. Well, he went on his installation routine, which was just written, as a shell script. In order to clear out his library directory and reinstall his RubyCocoa, he just deleted everything, rmrf, the library directory, which of course was his user library directory, and that was fine because he had no other things installed in his user library directory. But when I installed it on my machine, it deleted my entire system's library directory. Every library on OS X was removed, but the operating system was still running. I'm like, how is this possible? I just deleted everything. Basically all the system libraries were gone. I did an ls, and it was like, no files found. I'm like, oh my God, it's still running. This is freaky. So I slowly reboot my machine. I'm like, oh, this is horrible. Reboot, came back up, all the libraries were there. Apple shadows your library directory just in case you do something exactly like that, right? But I actually contacted Hissa and said, you might want to change that code really, really quickly before somebody else does what I just did. And his response was, why did you install it in the system library directory? Anyway, so RubyCocoa, kind of fun. RubyCocoa is bundled with OS X 10.5. It is stable. As a matter of fact, Apple supports RubyCocoa for development. Apple has products that ship with, for example, OS X server that are written in RubyCocoa. So they support RubyCocoa as a programming model for developing applications on OS 10, and they will for probably the next 2 or 3 releases of OS 10. This is what a hello world, sorry if you can't read that in the back, but this is what a hello world, and of course in Ruby, hello world is like, puts hello world, or p hello world. But this is a wonderful looking hello world, but it actually does it in a window on the screen. But what's cool about this is you're actually able to require OS 10 Cocoa, include that, build applications. You're able to connect and work with all of the classes that are in Objective-C, all the classes that are in Cocoa, from Ruby. And so Ruby Cocoa lets you do this. Now there are some issues with Ruby Cocoa. The biggest one is it's a bridge. So the way Ruby Cocoa works is you have a bridge between, you have Ruby running in a process, and then you actually have the Objective-C runtime as well. And it bridges between the 2 languages. So both runtimes sit parallel to each other. And there's code that's basically sending requests back and forth between the 2 runtimes. So when you create an object in Objective-C, say you're creating a window, the window is created in the Objective-C runtime. There is a proxy object created in the Ruby runtime that points to that. And then every time you invoke a method on it, it marshals that across to Objective-C, and then it brings it back, right, the result. And so that's considered a bridge. And there's a problem with bridges. They cost something, right? It's a toll bridge. It costs money to go across it. In this instance, it costs performance, a lot of performance. Also, with 2 runtimes, there's 2 garbage collectors. Ruby has a garbage collector, right? We don't think of allocating memory and things like that. It's garbage collected. So when I create an object and I stop referencing that object, it's garbage collected. It gets really tricky when you have 2 different garbage collectors and you need to be able to keep them synchronized. And so that's actually a huge issue with Ruby Cocoa that people get bitten by. It just starts filling up using too much memory because the objects aren't being garbage collected correctly across the bridge. Ruby uses green threads. So Ruby 1.8 doesn't use native threads. Or really, it uses 1 native thread, I should say. When you start a Ruby process, Ruby 1.8.6, you don't have native threads, which means you can't use your multiple cores in your computer or your multiple CPUs if you've got multiple CPUs with one Ruby process. Now, Ruby has threads in it. You say thread.new and it works. And those are called green threads. They're all managed inside of Ruby. All of the I.O. inside of Ruby uses non-blocking I.O. So when you read a file or you're reading things off the network, you can do that with threads in Ruby, and it seems like everything's working concurrently, and it is. But the minute you call like a C function, if it does something for some period of time, that stops the entire world of Ruby with green threads. It will just stop it because it's really only 1 native thread going through Ruby at a time. But Objective-C is natively multi-threaded, as is Java, as is .NET, and things like that. So it's natively multi-threaded. The UI is natively multi-threaded and things like that. So because Ruby's using green threads and Objective-C is out here using native threads, there was this problem with what if multiple threads in the Objective-C runtime were trying to call into this one Ruby bridge. And so that was a complexity they had to deal with. It's just a horrible thing. And the messaging syntax is different. So I'll talk about this a little bit. What do we mean by the messaging syntax? In Objective-C, there's this thing called a selector. We call them methods in Ruby, right? So when I have a method, like say I have a method called initialize, right? Method we create when we initialize an object. You say def initialize. I want to initialize an object. And then I have parameters to that. In Objective-C, their selectors are actually more sophisticated than Ruby's selectors. So our selector is really the word initialize. It's selecting what method to call. In Objective-C, you have something like init with content rect, style mask, backing, defer, . Between all those colons is a parameter. Now it's not typed. You aren't typing that parameter, but it's actually a parameter. So that method is different than a method that left off the word defer with a colon on the end. So in that way, it's almost like, in Java, you can actually have multiple methods that are the same name, but based on the type of the parameter, and the type that you call it with will actually dispatch to that, right? It's polymorphic. In Objective-C, they don't have that. But they use this technique to actually achieve something very similar. So maybe they'll have init with content rect, style mask, and that's it, right? No backing, defer. Those are two different selectors. Now in Ruby, we actually don't have that colon syntax. We just have this first thing here. And so with RubyCocoa, this is what, well, actually, this is in Objective-C how you would call that. So I would create an NS window, init with content rect, so you have a colon, and then I have the parameter, so I'm making a rectangle there. And then style mask, and then I'm actually passing a bunch of constants, backing, and I'm passing another constant, and then defer. So that, and if you notice, there's just spaces after this. So it's like this, space, then that, and then space, no commas or anything. Objective-C takes that call and makes it a single selector, and that's the method it dispatches to. So the way RubyCocoa did this is you had to use underscores in replacement of those colon operators. And so you would say init with content rect underscore style mask underscore backing underscore defer, and then pass the 4 parameters that actually matched those different 4 positions. Now the problem with that is you're always counting. It's like, okay, let's see, 1, 2, 3, 4, 1, 2, 3, 4. The other problem is Ruby has a couple methods that have underscores in it, right? Like thousands of them that have underscores in them. Everyone uses underscores. Does anyone know why underscores were chosen instead of camel case in Ruby? Anyone ever wondered why? Yeah, the Japanese have a more difficult time reading the code if it uses the camel case, the capitalization, than they do if it's separated. And so and when Matz wrote it, he used the underscore because it was easier for them to actually read the words. And so now we have the arguments between camel case and underscore notation, and we think underscores rule. Anyway, but the problem was when you had underscores, RubyCocoa had to discern between whether you were actually calling an Objective-C function or method and whether it was 2 parameters or whether it was 1, because they had the underscore there and they were trying to discern that. So RubyCocoa's calling syntax is a little odd. I'd say it's really odd, but that's all that they had to work with at the time. So enter MacRuby. So again, MacRuby started in late 2007. MacRuby's calling syntax looks like this. MacRuby, by the way, is based on Ruby 1.9, and I'll talk about that in a second. But MacRuby's calling syntax looks like this. Init with content rect, and there's a rectangle, comma, style mask colon this. There's a comma there, backing, comma, defer. That's actually just a hash. So in Ruby 1.9, you can actually use this syntax to do a hash just like that. It's the same. They interpret this as going to be a symbol, and the thing on the right is going to be a value. So it's key value. It's just a hash. So it's like that. So we can write a Rails code like that now in 1.9 and really freak people out. You know what it looks like. So really what Laurent did when he was implementing MacRuby, the first thing he did is, so really what this method call is init with content rect, and then you're passing the first parameter is this array. The second parameter is a hash. So this is, again, very similar to what we see in Rails, where you have the first parameter is something and then an options hash follows, right? Like find one, or the ID of something, and then you can give options and do things like that. And it was just something that people fell into. Well, Laurent interprets this differently. So hashes in Ruby 1.8 aren't ordered. You add a bunch of keys into your hash, and the keys come out in a different order than the way you added them. In Ruby 1.9, they're ordered. So Laurent took advantage of that, ordering. And so this hash, when he actually sees that the second parameter is a hash inside MacRuby, he actually says, is this going to form a selector for Objective-C? So in other words, the ordered hash of these keys, are these keys all combined going to form a selector? And if they are, I'm going to actually call that Objective-C selector. If not, then I'll just call a method called init with content rect with the options hash to follow. So that's how MacRuby actually does that. So the MacRuby hello world, this is the only change between the RubyCocoa hello world and the MacRuby hello world. At the top there, it was how you create your window. Most of the other methods only took a single parameter, so you didn't have the underscores and things like that. Introduces a method, which I'll talk about a little bit, but it's called framework. So in Objective-C, you have this concept of frameworks. A framework is really a collection of classes and constants and things like that. Cocoa is a framework. WebKit is a framework. QTKit is a framework. All these things are frameworks which ship with your operating system. And so the framework method, which is in kernel in MacRuby, loads that framework's constants, classes, everything that you need to use that framework. And so when you say framework Cocoa, all of Cocoa's constants gets loaded. And I'll show that in code in just a second. And so I create the app, and I create the window, and it comes up with Hello World. So here is what MacRuby looks like from a stack perspective. MacRuby 04, which I'll call latest stable, we're very close to releasing 05, and I'm going to talk about that in a second, started with the Ruby 1.9 source code base. And the reason it started with 1.9 is Ruby 1.9 is natively threaded. So there's multiple threads of literal, when you say create a thread in Ruby 1.9, it's a system thread. It's not a green thread anymore, it's a system thread. Now, Ruby 1.9 has what's called a global interpreter lock, which means that although there's native threads running around, only one of those threads can enter the interpreter at a time. So if one of those threads goes into the interpreter and does something, the interpreter will effectively block all the other native threads from getting into that interpreter. So although it is natively threaded, there is the global interpreter lock. Python has the same thing. But Laurent started with 1.9. Through version like 0.1, 0.2, 0.3, up to 0.4, he started getting rid of parts of 1.9 and replacing them with their Objective-C equivalents. So in the beginning, he unified the object models. So in MacRuby, when you create a class in MacRuby and just say class foo end, that's actually an Objective-C class. When you have a class like NSWindow, if you say NSWindow, that's a Ruby class, but it's also an Objective-C class. They're unified. Every Ruby object is an Objective-C object. So if I just say, object.new, any Objective-C, it actually descends from, and I'll show this, NS object, which is the root object in OS 10. I'm sorry, in Objective-C. Every Ruby method is available to Objective-C, and every Objective-C method is available to MacRuby. And then it unified the dispatcher and garbage collector. So in the beginning, it was just, I want to unify these things. First thing he started to do is say, I want a Ruby string to be based on the foundation string inside of OS 10, which is called CF string, core foundation string, or NS string. That is a very rich object. There are so many methods on CF string available to it. And Ruby has a lot of methods on string as well. And so Laurent has a very clever way of hiding the fact that there's all these additional methods on it. But when you actually create I'll actually show this real quick. When you create a MacRuby string, you actually create an Objective-C string, and I'll show that. All right. So let's do this real quick. So when you install MacRuby, it prefaces it puts a prefix on every program that you install. So normally you would do IRB for interactive Ruby. It prefaces everything with Mac. So MacRuby, right? So MacRuby is the command instead of Ruby. MacIRB is IRB. MacGem is gem. MacRake is rake. So it prefaces that. And they do that so that you don't overwrite your Ruby interpreter when you install MacRuby. So we'll do MacIRB. And I'm going to say, S equals rich. So I have a string. If you look at the class of that, it's actually an NS mutable string. So the term mutable it's changeable, right? There's a thing called an NS string and then an NS mutable string. And in Objective-C, they have mutable equivalents of their basic types. So an NS string is actually not changeable. Ruby strings can actually be changed. That's why it's based on this. So, so I have my S thing, and if I do methods, those are my methods. Now, those methods are actually the same methods that you would get in, mostly, the same methods you would get in 1.9. All these methods that are on here. Center, cares, case compare, all these things like that. But if you do methods, you pass true, true, you actually get a whole bunch of other methods. So what Laurent did is he has, if you pass two trues, I forget what the first Boolean does when you say methods true. I think it actually shows you the methods of what are inherited on object or something like that. And by default, I think that's true. He actually took over the second parameter, which is unused in Ruby, and that parameter says, show me everything that's available through Objective-C on this object. So here, I'm looking at every method that is on here. And by the way, this is from CF string. There is a ton of functionality. Just like in Ruby, there's a lot of functionality in like string and array. There's an unbelievable amount of functionality in here of things you can do with strings. Internationalization, just but anything you could possibly, it's just an amazing amount of stuff. Like write to URL atomically encoding error. Isn't that awesome? I have no idea why you would use that. But this is a Ruby hash, right? So I have a Ruby hash. But if you look at the class of that, it's an NS mutable dictionary. So I've just created an NS mutable dictionary. Now, if you ever looked at the Objective-C syntax for creating an NS mutable dictionary, it's heinous. It's horrible. It's the worst thing you've ever wanted to see, pretty much. But with Ruby, you can actually just do this. And what's really funny is because when you create a hash in Ruby, it's actually an NS mutable dictionary. That means whenever you're calling an Objective-C method, the Objective-C method that requires a dictionary, you can just use a Ruby hash. And so the code ends up just looking so much better when you're using MacRuby to develop against an Objective-C library anyway, that it makes it fun. It's kind of crappy if you have to do it in Objective-C. Other people might argue that, but I wouldn't. So, but if you actually look at the methods on here, again, this is a hash. So I have my hash and I have my normal hash methods. But if you do true, true here, you see that there's a whole bunch of underlying things. Now the reason with that is if you actually do s.class, you saw that it was an NS mutable string. s.ancestors, oops, s.class.ancestors, right? So this is actually where things get interesting. A string in Ruby, in MacRuby, sorry, is an NS mutable string, which is actually a subclass of NS string, subclass of comparable, or mixes in that, and then NS object, and then kernel. So when Laurent merged these object models, not only did he merge in the inheritance from NS object, that's the root object in OS 10. See, if you do object.new.class, it's an NS object. So object is, in Ruby, is actually an NS object. So the root object is NS object. But Laurent still recognized that we have these mix-in ideas, right? Modules in Ruby are mix-ins. And when you mix in a module to, in your class, it actually creates a class proxy that goes right in the middle of your inheritance hierarchy. So if you ever wondered what happens when you take a module and say, I want to include this module in this class, what it does is you add your class, it inserts this proxy class that points to that module over here, and that is actually inserted above that class in the inheritance hierarchy, and then of course it's superclass and it's superclass, so it's inserted above that. And the root of that is kernel. So kernel is included in object, and so everything has kernel in it, except for basic object in 1.9. So this is the inheritance hierarchy. It looks different than regular Ruby, but this is how it is. It's completely unified. And of course, array, in the same sense, methods, true, true, you get all of the crazy OS 10 or Objective-C methods init with contents of URL. Bizarre, right? So these are all these methods that you have available to you in an NS mutable array. and that is an NS mutable array. So the first thing Laurent did is he unified all of these types. As a matter of fact, if you say one.class.ancestors, you actually, here, let's do that again. Fixed num, precision, integer, precision again, numeric, comparable, NS number, NS value, NS object. So those are the Objective-C things that are being mixed in with the same things that are basically in Ruby's inheritance hierarchy for numbers. It's just fascinating stuff. Look, it's double precision. Anyway, sorry, that's a joke. I have no idea why precision's in there twice. But a fixed num is an integer, and you get the point. Let's go back here to the presentation if I can find it. So that was the first thing that Laurent did, is he unified the object models. He unified, he was still using Yarv. Yarv is yet another Ruby VM, right? Because that's the way we have to name code these days. So Yarv is a virtual machine that ships with 1.9, which does accelerate things about 4 times over 1.8. It's much faster. And actually for like numeric calculations, it's much, much faster than 1.8. So in 04, he continued to use Yarv. The parser, of course. The parser is really the gold in Ruby. It's just probably the worst piece of code you'd ever want to look at. It's cool. But if you actually look at that, that was the first thing I ever did in Ruby. Somebody said, hey, anybody want to write tests for my library? This is literally like 2001. I'm like, awesome. I've never written tests before. I would love to do that. Okay, well, I'm writing a parser for Ruby in Ruby. Cool, I don't know what that is. That's awesome. And it said, okay, so in order to write the test, what you need to do is you look at this file called parse.y in the Ruby source code and not at my library. And you need to read parse.y and create tests that assert what will happen when you actually parse the language. And I was like, what? So I wrote that, and it took months and months and months. And I think we had 16-some thousand tests that actually asserted thing across the parser. Of course, like all projects, that died. But it was actually really interesting. So the parser is very hard to do, and this is why things like JRuby have taken so long, because of porting this parser and stuff, and the standard library that you ship with Ruby. So all of that was still part of 1.9. And then, but from Objective-C, we got these core foundation classes, the things I showed you, the runtime of Objective-C. In the early days, it was just unifying, and then Laurent replaced the garbage collector of Ruby, so the garbage collector of Ruby has been replaced with Objective-C's garbage collector. So when you allocate an object, it actually allocates the object off of Objective-C's garbage collector. It takes a little bit longer. I mean, we're talking about microseconds, but it's still a little bit longer to allocate an object with Objective-C's garbage collector. But Objective-C's garbage collector is a generational garbage collector. So, objects that are short-lived get cleaned up faster, and then longer-lived objects move off, and it's a very optimal garbage collector. This is the way things like Hotspot are written on Java as well. And then some of those built-ins, that was the things like string, array, and hash, of course, have been replaced by their Objective-C equivalents. Also, up to this time, in the beginning, Ruby had its own way of dispatching methods, and Objective-C had its own. By 04, Ruby and Objective-C methods dispatching was integrated, so there was a single method dispatcher, and it was Objective-C's. 05, which you can actually find, by the way, on MacRuby.org, 05 started, gosh, I think the development for it started in December, right? Not too long ago. Laurent said, I'm not going to actually try and mimic his accent, but he's like, I'm not really happy with Yarv. I can sometimes slip into it, and I just don't want to do that. I'm not trying to offend the Belgian, right, because they can really come back at you. He said, I don't think Yarv is going to cut it for us. I think we need a better, more efficient way of running MacRuby code because it needs to get closer and closer to Objective-C's performance. So he said, I think I'm going to try and write a new virtual machine. Okay, Laurent. And then that was right before Christmas. He went on Christmas break, and I got little emails from him every once in a while, and I can't believe this is actually kind of working. This is over like 2 weeks, right? So the core of it actually was working within like 3 weeks. And the technology he used to do that is LLVM. So LLVM is, I think, the lightweight language virtual machine or something like that. I forgot what. low-level virtual machine. I like lightweight languages, but I think low-level is cool. Anyway, low-level virtual machine. And what Laurent implemented is a virtual machine. It replaced Yarv, so Yarv goes away. But it actually has a just-in-time compiler. So what MacRuby does in 05, and this is actually in MacRuby's trunk, and there are nightly builds of MacRuby you can actually download. How many people here have a Mac? Just like to see hands. Okay, so you use OS 10. How many people that don't have a Mac have an iPhone? Not many. But that one person or whatever, you use OS 10 as well. But LLVM is a whole framework. It's massive. It's a massive library, but it lets you build virtual machines. I mean, that's the whole frame. And Apple hired the LLVM core developers. They work at Apple. So Laurent worked with them, and he's developed this JITting virtual machine for MacRuby. And what it does is it takes the abstract syntax tree of Ruby. So once the parser comes in, it builds in memory an abstract syntax tree. Normally, the interpreter runs across that syntax tree and runs it, right? That's what the interpreter's doing. It's walking that AST. That's why it's called interpreting. What LLVM does is compile that to native code. It compiles it to object code, to native code. So once the AST is actually brought into memory, it actually is compiled dynamically into native code. And so what you're executing is native code. This is really, really awesome. Because, but by the way, that native code, if you say, invoke a method on something, and then you say, oh, I'm going to redefine the method. In your code redefines the method that you're actually calling, that still works. It just recompiles that method dynamically. So it maintains all the dynamic features and behaviors of Ruby, but it runs at native code performance. And another thing that was part of this is an ahead-of-time compiler. So an ahead-of-time compiler says, I want to take Ruby code, and I want to compile that ahead of time to that native code. So I don't have to do it at runtime. And so that's what is included in 0.5. So it's a new virtual machine with ahead-of-time compilation, amazing speed increases, running Fibonacci, Fibonacci sequence, just computing a Fibonacci sequence. MacRuby is slightly faster than Objective-C. Yeah. So MacRuby is slightly faster than Objective-C in doing that. Objective-C is slower than C. So C for a Fibonacci sequence might take a second, and Objective-C is like 4 seconds. And MacRuby is like just under 4. It's a little faster because he does an optimization of the way like the methods are being dispatched and things like that because he's generating code. So he generates optimal code. It's pretty neat. 05 is now based on the Ruby spec project, which came out of the Rubinius project, and that was how does Ruby behave, or how can we know that this Ruby runtime actually is Ruby? What is the Ruby runtime? There's no paper spec for Ruby, right? Ruby is as MRI behaves. So the Ruby spec project said, let's write a whole bunch of specifications in code, and that code validates the behavior of the Ruby runtime. It conforms with MRI, and then Rubinius actually could run those and say, do we perform like that? Yes, because we run all these specs. And there are tens of thousands of these specs. MacRuby is passing, I think, 85% of them right now, and continues to actually pull them and actually push changes upstream. So they're participating, the MacRuby team is participating with the Ruby spec project, which of course is used by JRuby and IronRuby and everybody else. And so, but MacRuby 05 also has no global interpreter lock. So it's gone. Which means that when you have native threads, they no longer have to freeze the virtual machine. It's all concurrent, truly concurrent. Which is awesome. And it integrates Grand Central Dispatch. Mac talked about that a little bit yesterday. So what is Grand Central Dispatch? This is a Fibonacci sequence. So I've defined fib with an n, and I recursively call myself until the end. And it just adds the numbers together. And so what I'm doing is I'm building a dispatch queue, and I want it to be a concurrent dispatch queue. The problem with multi-threaded programming is not only is it hard to write it, so it doesn't deadlock and all the other things of multi-threaded programming, but the other problem is with multi-threaded programming is ultimately the reason we write things with multiple threads is to take advantage of multiple CPUs. Right? That's why we write multi-threaded programming. And as our computers, like my desktop, my laptop has 2 cores in it. I have 2 CPUs. Technically, I have 3. I have the GPU, right? The graphics processor is a CPU as well. And so Apple was the first operating system to ship, Snow Leopard shipped with something called OpenCL, which is the Open Computing Library. And it's like OpenGL for, it's like OpenGL for code. It's like OpenGL for computing. And Intel and a bunch of other people are behind this as well. It's not just Apple. But Apple was the first operating system to ship with OpenCL. And Grand Central Dispatch is their implementation of that. They just call it Grand Central Dispatch because it's cool, right? It sounds great. Typical Apple. But the reason they call it Grand Central Dispatch is this. So normally, you write your application, you write it with multiple threads. Somebody else writes an application, they write it with multiple threads. You write your application saying, I want to take advantage of as many cores as possible. Somebody else does the same thing, right? So ultimately, what will happen is you get a bunch of these things using and managing their own threads and possibly their own pools of threads. And the operating system on the whole is actually not able to observe what threads are necessary on the whole, right? It's just scheduling threads, and it sees everything as, well, God, I've got to schedule this thread, this thread, this thread. But the operating system can itself kind of observe all of that. What Grand Central Dispatch does is says, don't think in terms of threads. We'll deal with threads for you. Think in terms of queues. Build a queue, and you can think of a queue as a concurrent thing. Build a queue, push something on the queue, then we in the center, in the Grand Central, right, dispatch, we in the center will have a thread pool and queue those things up to run. But we will actually queue everything up so that it runs the most efficient way possible across whatever cores you have. So the great thing about this is then if all of the applications are rewritten, and Apple rewrote a lot of their own internal OS X applications, including Finder and everything else with Snow Leopard, to be based on Grand Central Dispatch and these queues. If everything is rewritten to use these queues, the entire operating system will do the most efficient mechanism possible to run everything concurrently over however many cores you have. It's a really great idea. They actually modified C in order to support this with a thing called blocks, right? In Ruby we have blocks, and it's kind of like that. It's a block of code, and you mark outside of it that, hey, I need this variable inside this block. So this block I want to run concurrently. Again, this is in C. This block I want to run concurrently, but I want this variable to be shared inside that block, which means you have to have mutexes around it and things like that, right? So you mark all these things in C, and then the operating system, as you compile it, deals with that, and deals with dispatching that into queues and multi-threading it and protecting access to variables. In Ruby, if you notice what I'm doing here in MacRuby, I'm saying 8 times do, group dispatch, put us Fibonacci 40. So that block of Ruby code is actually being added into a Grand Central Dispatch queue. And because the queue is concurrent, they'll actually run concurrently. And this is really awesome, because now I don't have to build threads. I just want these things to actually be done in parallel. So for example, the method collect on array, right? Collect iterates over every element of an array, performs some operation to that array, and returns back the result, right, as an array. It has the same number of items. It's just that same number of items with a block that was performed against each item. So it modifies it based on that block. You could and this is the goal, is to take methods like that in MacRuby and use Grand Central Dispatch. So collect will actually be a parallel operation, which is pretty neat. Which means that you just run array collect, and all of a sudden all your cores light up, because all your cores are actually being used to do that collect operation. So if your collect computed a Fibonacci sequence, you'd actually watch all your cores do that. I'll actually show that really quick. It's kind of cool. Sorry about that. So I've got this GSD thing here, or GCD, sorry. And when I run that with MacRuby, I don't know if you're going to be able to see this, but I've got my little CPU cores down here. I'll just click on that. We got my cores down there. So when I run this, so that's started. So both cores are being used in parallel. So you actually can see both things are being pegged. If I did this with Ruby itself, only one core would actually be pegged. The other core might actually be used because Ruby's like grabbing memory terribly fast, and so the operating system is going, oh crap, I've got to allocate a lot of memory and things like that. But that's not Ruby using that other core. Here, MacRuby is actually using both cores in this instance simultaneously. If this is on a quad-core Mac, it would actually use all four simultaneously, which is pretty cool. And so those operations would actually be done on 4 cores at the same time, and then the next 4 cores and the next 4 cores. So it's pretty neat. And that's actually built into 05 as well. So there we are. Ahead of time compilation. So with ahead of time compilation, I can take a Ruby file, this Grand Central Dispatch example I did, and I can actually compile it. I'll do that, actually. I need to do that. Actually, I have that command right here. So MacRuby C. Hello, MacRuby, not RubeC. It's a different app. MacRuby C lets me compile things and it gives me options. So what I'm going to do is I've got this thing here. Boom. So I'm going to run this command. And what this is going to do is it's going to compile that Ruby file to native code. If I actually look at this, I have this, what is it, 14 meg file? It's not optimized yet. But it's got this 14 meg file, which is all of MacRuby compiled into a native app with LLVM and everything else. Nothing else is needed. No Ruby code is needed at all. It compiles everything into this executable. All the standard library, everything it uses is compiled into that. If I run that, it's going to do the same thing it did before. It's going to run things in parallel. But I can take that file and give it to you on your Mac, and you can just run it. You don't have to have anything. So ahead of time compilation lets you do that. Now what's really nice is you can do that with a MacRuby written app that you write against, you know, the one I showed you where it actually, the hello world that pops up the UI and everything. You can write MacRuby apps using interface builder and using you know, Xcode, and you're developing your MacRuby app, but it's all in Ruby instead of Objective-C, but you can then compile that to a native app. And there is no Ruby code that you ship. So, HotCocoa. This is actually something I was working on for MacRuby. HotCocoa is an idiomatic Ruby API that simplifies the configuration and wiring together of Objective-C and Cocoa classes. Which means if you create a button in Objective-C, and you say, okay, I want to create a button, and then you have to configure the button. And it's like 8 lines of code to do that. What I thought was, wouldn't it be great if we could use things like Ruby hashes and Ruby, you know, the nice syntactic features of Ruby to make creating things like buttons easy. Or really all of these Objective-C classes that are big. I want to use Ruby to make it easy to do that. And so this is what it looks like. So this is that hello world program you saw before. And what I'm going to do is I'm going to click through and show how each of these lines gets replaced by a HotCocoa line of code. So the first one is that when line. I'm creating a window. Well, first you require HotCocoa and include it. So I create a window. So it goes from that to that. A little bit smaller. So I create a window with a title, hello world, and I set a frame. Now, all these other options that you saw there, that style mask, those are defaults. This is no different than when you go into Interface Builder in OS X and you actually say, I want to create a new window. All those little checkboxes you do, or that are checked for you by default, like whether you want a title bar and a border and stuff like that, those checkboxes basically are doing exactly what I do inside of HotCocoa, but I'm using code to set the defaults. They have little checkboxes that set the defaults. It's the same idea. So window becomes that. There's that button. So I'm actually creating a button, becomes that. So I create a button with a title, a layout. I want to align it in the center. And then I say window append button. So over here I had to say, I think window dot add, where is it down at the bottom there? You basically have to add it, add subview. You say window dot add subview button. I don't even think I do it there. You're supposed to. But here, all I have to do is say window append, because what you do in HotCocoa is we add the less than operator to window, NS window, that particular NS window, so that you can add a component to it. It's kind of neat. And then down below, you saw there that I created an object. I added a method called sayHello, and then I set the target and action. So in OS 10, there's this concept of target action on things like buttons. Target action says this is the target for that thing, and this is the action that I want it to perform, the method I want to call. So the target is the object, the method is the thing I want to call. In HotCocoa, it looks like this. b.onAction, I use blocks to do exactly the same thing. So I can say b.onAction, put us hello world, and just put my action inside that block. And then the other stuff that's around this, so creating an NS application, shared application instance, win, display, order front, becomes that. So that code is actually functionally equivalent to that code in HotCocoa. So it's kind of neat. And we're evolving HotCocoa because HotCocoa began as this thing which was this idiomatic layer, and then it was like, oh, it'd be so cool if we could just create entire apps this way. And so I created an app generator, and you could say HotCocoa from the command line and build an app. But then you were working just in Ruby code using HotCocoa. And then the question was, how can you use Interface Builder with this? How can you use all these technologies together? And there was another framework that was actually being used called Rucola that was actually built against RubyCocoa. And Rucola is an awesome framework. And it really does try to say, how can I write my Ruby code so that I can actually still use Xcode and still use Interface Builder, but also be able to do all this stuff in command line. Very well thought out program, very unlike what I did when I was doing my app generator. It's very, very well thought out and test driven. It's thought out from a testing perspective. So I still love this idiomatic thing, which I'm doing with HotCocoa, and it'll still remain. But, I'll talk about that in a second. So, but what's going to happen is the HotCocoa library and Rucola are going to become gems. So right now, HotCocoa is part of MacRuby. It is going to be extracted, put up on GitHub in the next week or so, and so that people can contribute to it. So HotCocoa will be able to have anyone contribute to it, and it'll become a gem. And so you'll say MacGem install. As a matter of fact, when you install MacRuby, it'll install that gem from the site. But we'll be able to evolve that very quickly and have a lot more open source contributors, because right now MacRuby is being done in Apple's Subversion tree, and it's actually available for folks, but you have to actually sign in, a thing from Apple and various things like that. So it's harder to contribute. So HotCocoa and Rucola is going to be how you build apps. HotCocoa is going to be this thing to simplify coding with these complex things. And what I was showing here is this is a new syntax that I'm moving towards. I used those methods before, but they created some kinds of headaches. So we're playing with some new syntax, which will be available soon. So I don't really need to cover that too much. So that actually is MacRuby and HotCocoa, and I just wanted to show. I mean, I didn't really get into examples and things like that. This is just a MacRuby app. This is the Flickr demo. There's a whole bunch of demo apps that come with this. But to show this thing performing, I mean, that's Ruby code, right? Doing this. Now, actually, that's not Ruby code at all. What that is this thing talking to this thing and telling these things to resize. But the thing that fetched the images from Flickr and did all this stuff is just Ruby code, and it's in an Xcode project, and you can edit that Ruby code. It's right here. You can edit it, and it's just Ruby. So I didn't get into how all this code looks and everything like that. This doesn't say that you don't have to learn OS 10 development, you don't have to learn the Objective-C library, you still do. But the goal of MacRuby is to say that you can work in your favorite dynamic language and be able to do that. So with that, going back to Alan, audio.
MacRuby is actually pronounced MacRuby, and HotCocoa clearly is HotCocoa.
Right. So Alan gave me that last night. HotCocoa, right? So we can't say HotCocoa, we have to say HotCocoa. And MacRuby. He was actually going to do an entire thing of the clan MacRuby, and the conquering of the clan MacRuby of the apples. But anyway, so that's it. So thank you very much.